All right, in this lesson, we are going to review solving one variable equations and literal equations. So we are going to start by solving one variable equations. And so looking at number one, it says solve for x. Okay, so here's x. Whenever I am dealing with an equation, I like to either imagine or draw a line where the equal sign is. And then anything on the same side as x, we have to get rid of it by doing the inverse operation. So here we have a plus 7. So to get rid of that, I have to subtract 7 from both sides. Whatever you do to one side, you have to do to the other. And so that would cancel, and my new equation would just have x equals, and then 15 minus 7 is 8. And so now that I know that x equals 8, I'm done. Okay. That was a one-step equation. Here we're going to have multiple steps because x has two numbers with it. We have a times 3 and a plus 4. Always get rid of the number that is not attached to your variable. That 3 is attached, so we are going to get rid of the 4 first by subtracting, leaving me with just a 3x equals, and then 19 minus 4 is 15. And then now we're still trying to isolate x, so we have to get rid of that 3. It is being multiplied, and so that means we need to divide. And so that leaves me with x equals 5. Okay, in this next example, I have my equal sign, and we are solving for x, but it's currently in two places, and they're on the same side of the equal sign, which means we can combine like terms. 4x plus 2x is 6x. We still have that minus 3. Those can't combine because they're not like terms. And so now we're back to what we were doing in the previous example. We're still solving for x, but we have to add 3 first. That has to happen first. And then we are ready to divide by 6. We get x equals 3, and we're done. Okay, for number 4, here's my equal sign. And then once again, I see x in two places, but this time we can't combine them. They're on different sides of the equal sign. And so what we have to do is pick a side to get rid of all the x's on. And so I'm going to pick the right side because there's less of them, and I'm going to take away all 3 x's. Whatever you do to one side, you have to do to the other, and so that's going to affect the 5 x's on the left. Okay, and so that leaves me with 2x plus 2 equals, and then just a positive 10. So we're just writing 10. Okay, here's x. Now we're ready to isolate. First, getting rid of the plus 2 by subtracting 2. Always get rid of what is not attached to your variable first. And now we can divide by 2. And so x equals 4. Okay. In this next example, there's 2 steps you could approach. So here's my equal sign. Here's my x. He's in a set of parentheses. And so we could either distribute, those parentheses mean distribute, or we could go ahead and get rid of the 3/4 by doing the inverse operation. And so instead of multiplying it into the parentheses, we're trying to get x by itself. And so a better strategy is to go ahead and get rid of this. The way you get rid of multiplying by a fraction is you could divide both sides by 3/4, but that is the same as multiplying by the reciprocal. Dividing by a fraction is the same as multiplying by its reciprocal. And so multiplying both sides by 4/3 would get rid of that, leaving me with just the x plus 2. So don't distribute it, just get rid of it. Okay, and so to take care of 18 times 4/3, that 3 is on bottom, so that reads 18 divided by 3, which is 6, and we still have the times 4. So you're dividing by the bottom number, multiplying by that top number 4. And so that gives me x plus 2 equals 6 times 4 is 24. Subtract 2 from both sides, and that gives me x equals 22. Okay, this next example, we have a lot going on, so we have a lot of cleaning up to do. Once again, I have sets of parentheses, but then we also have additional stuff. And so we actually do have to distribute in this problem. Okay, and so distribute means multiply. So that leaves me with 3x minus 12. And then we still have that minus x that's unaffected. It was not in the parentheses. And then distributing the negative 2 gives me negative 2x plus 12. Now, the reason we didn't have to distribute is because we only had one set of parentheses and nothing after. Okay, this one's different because we have a minus x after. Plus, we have parentheses on both sides, and so the best strategy here is you have to go ahead and distribute. Okay, and so now I'm noticing I have x in two places on the left side, which means I can combine my like terms. 3x and negative x is technically 3x minus 1x, which gives me 2x. And then we still have this minus 12 unaffected. And then I have a negative 2x plus 12 on the right-hand side. Okay, now I have x's on both sides. We can't combine them, so we pick a side to get rid of all the x's on. So picking the right-hand side, we would add 2x to both sides, leaving me with a 4x minus 12 equals 12. Okay, now we have x just in one place. We are ready to isolate him. You're not ready to isolate x until it's only one x term. So we would first add the 12, leaving me with 4x equals 24. And then lastly, divide by the 4, and we get x equals 6. Okay, over here, we have one set of parentheses, but we have x on both sides, so we do have to go ahead and distribute. So 4x plus 4 equals 4x plus 4. Now, just reading that, you can see the left and right-hand side are the same. And so this is a special case where the solution is all real numbers. But let's say you didn't notice. You would pick a side to get rid of all of the x's on. And when I pick the right side, it ends up canceling all the x's on the left as well, leaving me with just 4 equals 4. That's true. Whenever x drops out of your equation and leaves you with a true statement, your solution is all real numbers. Any value of x would work for this problem. Okay, over here, we have x on both sides of the equal sign. And so when I pick the right-hand side to get rid of all the x's on, they cancel. But this time it leaves me with a false statement. 3 is not equal to 7, so this one has no solution. No value of x would work for this equation. It will never be true. Okay, in these next examples, we are solving what is called a literal equation. And so it's usually a formula with 2 or more variables. So you're going to see a lot of letters. The goal is to solve for one specific variable. And so we solve it just like we did above, only we're not going to be able to number crunch. We're not going to be able to simplify. We're still just going to have a bunch of letters. Okay, so looking at number 1, here's my equation. And we are solving for W. It's being multiplied by L. And so to isolate W, I would divide both sides by L. Now that leaves me with just W on the right and A divided by L on the left. And so when I write my final equation or formula, it would say W equals A divided by L. And that would be my final answer. We can't simplify that. Okay, on number 2, we're solving for x. Okay, and so we treat m and b kind of like they're numbers, but we can't number crunch. And so we always get rid of what's not attached to the variable. And so this plus b, we have to get rid of that first by subtracting b. Okay, and so on the left-hand side, I have y minus b. Write it in the same order. And then I have m times x. Still solving for x, right now it's being multiplied by m, so we have to divide both sides of the equation by m, the entire side. Okay, and so that leaves me with x equals y minus b all divided by m. And that's the best we can do. X is isolated, that means we're done. Okay, on number 3, we are solving for w, just the w. And so the first thing we have to do is get rid of what's not attached to our variable. This 2 is attached, so we're going to leave it alone, but this 2L is being added, and so we need to subtract it from both sides, the whole 2L. We don't want to isolate L, we want to isolate W, so that whole 2L has to go, just as if it was like a 5. I would subtract 5 from both sides. Okay, that leaves me with P minus 2L on the left equals a positive 2W. Still trying to isolate W, and so my next step is to divide by that 2, the entire left side. Okay, and so that leaves me with W all by itself equals P minus 2L all over 2. P minus 2L all over 2. Another way you could write this answer is to separate the numerator. And so if I were to separate the numerator to each be over the 2, we could actually simplify a little bit further. And we have 2L divided by 2. In this case, the 2's would cancel, leaving me with just P over 2 minus L. Notice that P is still over 2. That's why you can't just cross off the 2's in this step up here. You have to separate the numerator so that P remains being divided by 2. And so this would be an equivalent answer. And on multiple choice, either of these could show up. They are equivalent. Okay, on number 4, we are solving for h. Okay, and so I'm seeing a fraction. Instead of dividing by 1/3, that looks pretty ugly. You don't want a triple layer fraction. That's not simplified. So instead of dividing by 1/3, that's the same as multiplying by the reciprocal, which is 3 over 1. So we are going to multiply both sides by 3 to get rid of that 1/3. So that leaves me with 3v equals b times h. Still trying to solve for b, we would now divide both sides by b. Okay, and so that leaves me with h by itself, 3v divided by b. 3v divided by b. Now, I want you to know that if, and I see this a lot, you had 1/3 b on bottom, that's not wrong. It's just not simplified to have a fraction within a fraction. Okay, and so the best answer and the way you would need to write your final answer is 3v over b. Okay, this next one's challenging because x is in the bottom of a fraction. And so the first thing we have to do to solve for x is get him out of the denominator. And so the way we do that is we go ahead and multiply both sides by x, even though that's what we're solving for. It's not usually what we would do, but we have to get him out of the denominator. And so if I multiply both sides by x, that would cancel on the right, leaving me with just an a. And then I would have 25 times x on the left side. And we write the number before the variable. That says 25 times x, and we're still trying to solve for x, but now he's outside of the fraction, and so it's easier to isolate him. We just have to divide both sides by 25. Okay, and so x equals a divided by 25. Okay, last one, we are solving for r. He's currently being multiplied by 2 pi. And so we can go ahead and divide by 2 pi in one step. Divide by 2 pi. And that leaves me with r all by itself, and then c divided by 2 pi. So r equals c divided by 2 pi.